pilot operated relief valve versus direct acting relief valves. This is the schematic of a direct acting relief valve, and often it's also the same schematic of a pilot operated relief valve. However, if we do actually have a pilot operated relief valve, the schematic looks more like this one over here. The difference between one and the other one is that a direct acting relief valve only has one relief valve, and I mean one puppet with one relief valve, and the pilot operated relief valve has two puppets. One is the main puppet, this one over here, and then it has a secondary relief valve with a second puppet, which is on the pilot line, that helps to keep the main body of the valve closed. So a way that a relief valve works, if you think about it, is very similar to a check valve. They're not check valves, but they work kind of the same way, in which you have a spring that is holding a puppet into position, and it doesn't allow any flow to go from one port to the other one. And so when pressure increases, it breaks the resistance of the spring, and it allows flow to go through the other side of the valve. So let's say that you have a valve that is 2000 psi. 2000 psi. And you have flows, let's say, for this example, we're going to say 20 GPM, 40 GPM, and 60 GPM. Well, the valve is going to start cracking open before the 2000 psi. The spring is going to start moving before the maximum setting of the 2000 psi. And the higher the flow, the more leakage you're going to have across the valve. So a direct acting relief valve, like this check valve over here, is going to start cracking open, and it's going to start having leakage, let's say 1800, let's say 1700 psi, and then you have inefficiencies in the system, right? So you want a way to minimize that loss, of flow, and minimize the moment that the valve opens and closes when you want it to be ideally at 2000 psi. So one way to minimize it is by using a pilot operated relief valve. A pilot operated relief valve has a spring, a light spring over here, that is usually, depending on the manufacturer again, but it's usually low pressure, let's say 50 psi on that spring. So if you want your valve setting to be 2000 psi, then on this valve over here, you have 50 plus 1950 is going to give you the 2000 psi that you need of resistance on the valve. During the operation of this valve, when pressure is increasing, let's say you have a working system, and let's say at the moment you have 1500 psi. When you have 1500 psi, you have 1500 psi going up in this direction, trying to open the valve, and through the pilot line, you also have the 1500 psi working against the valve in this direction. Plus, you also have the 50 psi from the spring over here. So you have, on one side you have 1500 on the bottom, and on the top you have 1500 plus 50. So you always have higher pressure from the top of the valve to help it keep it closed. Once you reach the pressure to be at 1950, Now this valve open over here. So you have 1950 plus 50, you have 2000 psi pushing it down, while on the other side you only have 1950 psi trying to keep it open. So the valve is still closed. The main body valve is still closed. However, the secondary valve opens and it allows some fluid to go through the pilot line. Very, very, very little fluid goes through the pilot line, and now you have some leakage at 1950 psi that is going to be much different than the leakage that you had from a direct acting relief valve that maybe start cracking at 1700 or 1800 psi and have the leakage of 20, 40, or 60. A portion of that flow as a leakage versus just a leakage coming from a pilot line. So right there you are improving on the performance of the valve because you have a much lower leakage at a higher pressure setting or a pressure setting that is closer to the maximum setting. Once you go past the 1950 psi, now the system, it doesn't increase pressure on the pilot line over here anymore because at 1950 is dumping it back through the pilot line, so it cannot go any higher from this valve setting anyway. The only pressure that is left to beat is the 50 psi from the spring, the 50 psi from the spring over here. So as pressure keeps increasing from 1950 to 1960 to 1970, then you're gonna having a little bit of crack on the spring, and now you're gonna have some crack on the main body valve, and you're gonna then at that moment you're gonna see some of the leakage of the 20, 60, 40, or 60 GPM. Now that leakage occurs on pressures that are above 1950 psi, which is again a much higher pressure than the 1700 or 1800 psi that was leaking before. Once the pressure reach 2000 psi, now it beats the resistance of the secondary valve, and it beats the resistance of the spring. So you have 2000 psi, the valve opens completely, full flow goes through the relief valve, and then the valve is open. So that's the difference on how a pilot operated relief valve works. Then when the pressure drops below the 2000 psi, then this spring over here start pushing back on the body and try to close it. Once it goes below the 1950 psi, then you have the 1950 plus 50, you have 2000 psi pushing it down, and the valve completely closes. So the difference between one and the other valve is basically the efficiency of how it works. You have much loss of a much lower loss of flow from a pilot relief valve. You also have a closer opening and closing of the valve close to the maximum pressure setting, and on top of that it's a much quieter valve. So the direct acting valve has a lot more noise when it has the cracking. It's much noisy, and the pilot operated valve is just quieter. So yeah, that's the difference between one and the other valve. If you have any questions, just leave a comment below or send me an email. Thank you much for your attention. We'll see you next time. Bye bye.